Good day everyone, I am JMBFelipe from Calamansig, Sultan Kudarat, taking civil engineering major in transportation. I finished my elementary in Dato Gebar Pilot School, then I finished my high school in Calamansig National High School. In my senior year, I got to Libak Legislative National High School, and in present day, I am studying in University of Mindanao. So before we begin, we will talk about this first. In future administration, what changes do you want to be implemented? Filipinos are facing a lot of struggles, but the amount of change we've gone through is a lot compared to the previous three administrations for better. Corruption, price hike, unemployment, crimes are still present and will ever be problem in our country but has been better, and I hope we can keep improving ourselves for good. The next presidential election is nearby. I hope we can keep on track on what we're currently still trying to improve, to try fight against inflation and continuation of the Build program, lessening our imports and strengthen our export, sourcing local products and encouraging the use of the local goods, free low-cost quality education, free low-cost healthcare, and much more. Filipinos need the next president to be better than the current, if not the best. What is your favorite color and how do you associate this color in your life? I like green because green symbolizes aspiration, resumption, and peace. I love green so many reasons, and here are some that I thought were the most important. Green is color of life. According to my research, green is universally associated with nature, linked as it is to grass, plants, trees. It also represents growth and renewal and being the color of the spring and rebirth. So lastly, what is or are your expectations in this subject during the duration of this class? My expectation in this subject is to learn more so that I can apply what I've learned in my profession. So my report is all about road vehicle performance. This topic, it gives insight to highway design and traffic operation as well as the trades-off required to handle the vast range of vehicles that utilize highways from high-power sports cars to massive heavy trucks. It forms a basis from which the impact of advancing venue technologies on existing highway design guidelines can be assessed. So what is road vehicle performance? The performance of road vehicle forms the basis of the highway design guidelines and traffic analysis. So the vehicle performance is an important factor in selecting the design of the traffic control device, the setting of the speed limit, and timing of operation in traffic signal system. Here are the illustration of the forces acting on road vehicle. Then we have three major sources of vehicle resistance. First is the aerodynamic resistance, next is the rolling resistance, and third is the grade or gravitational resistance. First is aerodynamic resistance. Aerodynamic means the study of the properties of moving air and interaction between the air and solid bodies moving through it. So the aerodynamic resistance is the resistive force that can have significant impact on vehicle performances. So this is the equation in determining the aerodynamic resistance, which the RA is the aerodynamic resistance in pound, the ρ is air density in slug per feet cube, the CD, coefficient of drag, unitless, the AF is the frontal area of the vehicle. Then the V is the speed of vehicle in feet per second. So next is the rolling resistance. The resistance caused by a vehicle internal mechanical friction as well as the pneumatic tires and their contact with the roadway surface is referred to a rolling resistance. Depending on the vehicle weight and the material composition of the roadway surface, the penetration of the tire into the surface and the corresponding surface compression can also be significant source of the rolling resistance. Three factors in considering the sources of rolling resistance. First is the rigidity of tires. The tires and the roadway surface influence the degree of the tire penetration, surface compression, and tire deformation. The hard, smooth, and dry roadway surface provide the lowest rolling resistance. Next is the tire condition. Including inflation, pressure, and temperature, we can have substantial impact in rolling resistance. We can see in this picture, in this image, under inflation and the overinflation, we can see the difference with the tire that has a correct pressure amount of air pressure. Next is the vehicle operating. Next we have the vehicle operating speed, which affect the deformation. Increasing speed result in addition in tire flexing vibration, thus a higher rolling resistance. So last is the grade resistance. Grade resistance is the most basic type of resistance. It is gravitational force exerted on the vehicle. This force could not be perfectly perpendicular to the road surface, especially if there's a gradient. So the expression for the grade resistance Rg is equal to W sine sub G. As in the development of the rolling resistance formula, highway grades are usually very small, so sine theta G is equal to tan theta G, where R sub G is equal to W tan theta G is equal to WG, where G is grade defined as the vertical rise per some specified horizontal distance opposite side of the forced triangle divided by the adjacent side of the feet per feet. So next is the vehicle acceleration. So what is a vehicle acceleration? So it is a study of the vehicle in motion and its behavior during the interaction of the driver. It is defined as the available tractive effort F that can be used to determine a number of vehicle performance characteristics including the vehicle acceleration and top speed. For determining vehicle acceleration can be applied with an additional term to account for an inertia of the vehicle's rotating parts that must be overcome during acceleration. So
Car is
here
traveling at
is
10
the
miles per
example
hour on
of
a
the
roadway
vehicle
covered with hard packed
acceleration.
snow. Coefficient of road adhesion is given as 0.2. So the car has a value of C sub D of 0.3. The A sub F is equals to 20 feet squared. And the weight of the car is given as 3,000 pound. The wheelbase is 120 inches and the center of gravity is 20 inches above the roadway surface and 50 inches behind the front axle. The air density is 0.002045 slugs per cubic feet. The car's engine is producing 92 foot-pound of torque and is in a gear that gives an overall gear reduction ratio of 4.5 to 1. The wheel radius is 14 inches and the mechanical efficiency of the drivetrain is 80%. If the driver needs to accelerate quickly to avoid an accident, what would the acceleration be if the car is, for letter A, if it's front-wheel drive, and B, if it's a rear-wheel drive? Okay. So the solution is as follows. So we begin by computing the resistance tractive effort generated by the engine and mass factor because all of these factors will be the same for both front and rear wheel drive. So the aerodynamic resistance, so from equation 2.3 is given by this equation. So again, RA is equal to rho over 2 times C sub D times A sub F multiplied by B squared. Okay? So given naman yung rho mo as 0.002045, so over 2 times C sub D, so 0.3 times A sub F na 20, and then given yung velocity mo as 20, so kinonvert niya lang to feet per second. Okay? So alam niyo naman kung paano mag-convert. So 5280 divided by 3,600 and then squared. So the answer for RA is 1.32 pound. Next will be for the rolling resistance. So given in the equation 2.6 as R sub RL is equal to F sub RL times W. So given naman yung F sub RL mo as 0.01 and then yung W mo is equals to 1 plus 10 times 5280 over 3,600 over 147 and then multiply by 3,000. Okay, so that is 32.99 and ito pala guys, yung W mo is yung 3,000. So itong F sub RL mo, ito, part pa siya ng equation na to. Yung 0.01 times the quantity of blah. Okay, so for the engine generated tractive effort, so given on equation 2.17, so we have an equation of F sub E is equal to M sub E times epsilon sub O times N sub D over R, or that will be 95 times 4.5 times 0.8 divided by 14 over 12. So the answer for F sub E, or the engine generated tractive effort, is 293.14 pound. And for the mass factor, so from equation 2.20, so that is gamma m is equals to 1.04 plus 0.0025 times epsilon sub O squared, or 1.04 plus 0.0025 times 4.5 squared, or the answer is 1.091. And then upon getting the mass factor, so recall that to determine the acceleration, we need the resistance already computed earlier and the available tractive effort F, which is the lesser of F sub E or F sub max. For the case of the front-wheel drive car, so equation 2.15 can be applied to determine the F max. So ito yung equation na gagamitin natin. So F max is equals to mu, or the coefficient of friction, times W times the quantity of I sub R plus F sub RL times H over L, and then 1 plus mu H over L, or simply substitute all the given in the problem. So 0.2 times 3,000 times 70 plus 0.011 times 20 over 120 plus over 1 plus 0.2 times 20 over 120. Or the answer for a front-wheel drive, so kung ano yung hinahanap dito, so that is if the driver needs to accelerate quickly, so what would the acceleration of the car is if it's in front-wheel drive. So ito yung sagot natin for letter A. Okay, so next, so that's for a front-wheel drive car, so 293.14, the lesser of 293.14 and 339.77. And the acceleration is given from equation 2.19 as follows. So F minus the summation of R, or delta R, is equals to gamma M times MA. So in order to solve for A, ito nga yung hinahanap sa problem, so that is acceleration is equals to F minus summation of R, or the delta R over gamma M times M. Or just substitute the value, 293.14 minus 34.31 over 1.091 times 3,000 over 32.2. So the answer for letter A is 2.546 feet per second squared. And for the case of the rear-wheel drive car na bubulol, so equation 2.14 can be applied to determine the F max. So substitute mo ng value to find the F max considering a rear-wheel drive. So 0.2 times 3,000 times 50 minus 0.011 times 20 over 120 over 1 minus 0.2 times 20 over 120. So the answer is 257.48. And as for a rear-wheel drive car, so 257.48. So if the lesser of 293.14 and 257.48, and the acceleration is from equation 2.19. So I-consider natin yung lesser, so that is yung 257.48. So ganun lang din, yung kagaya ng anina. So F minus delta R over gamma M times M. So 257.48 minus 34.31 over 1.091 times 3,000 over 32.2. So the answer is 2.196 feet per second squared. So as you can see, mas mabilis yung acceleration natin do sa front-wheel drive compared kay rear-wheel drive. Ano? Meron pa bang rear-wheel drive?
So thank you everyone and have a good day.